Okay, I want to do an example of a telescoping series as well. Other than geometric, this is the only series that they will actually ask you to find the sum for. So we want to be able to do that. It also gives us a review on partial fractions. So it's not enough to say that this series converges. We're also interested in what it converges to. We look at this and we say, oh, we can turn this into a partial fraction expansion. So let's do that off to the side. 1 over n times n plus 3. Remember how this goes? We have, once it's all nice and factored, we can turn this into a over n plus b over n plus 3. And then what happens is you take this whole equation and you multiply by the denominator over here. So n times n plus 3. The point of that is to get rid of all the fractions. So you multiply the left side by that term, you should see that you just get 1. And then we multiply the right side, both of these. So we multiply it by the a term, we're going to get a times, I'll just write it out, n times n plus 3 all over n plus b times n plus 3 over n plus 3. Hopefully you can see what happens here is this n cancels, this n plus 3 cancels. So we get 1 equals a times n plus 3 plus b times n. Alright. Okay, so you can pick some convenient values to figure out what a and b are. So let's start with n equals 0. So why did I choose n equals 0? Because when I plug n equals 0 in here, this term is going to drop out, and I'll just have an equation in a. So n equals 0, I get 1 equals a times 0 plus 3 plus b times 0. Simplify this a bit. 1 equals 3a plus 0. So this implies that a equals 1/3. Alright, choose another convenient value. Maybe n equals -3. I'm picking n equals -3 because that's going to make this term drop out now. So I get 1 equals a times 0 plus b times -3. So simplify this a bit. 1 equals 0 minus 3b, which of course implies b equals -1/3. So my series is actually equal to one over 3 over n minus or plus -1 over 3 over n plus 3. Simplify this a bit. 1 over 3n minus 1 over 3n plus 9. Okay, now I'm just going to write out a few terms until I see what's happening. So for n equals 1, I'm going to have 1 over 3 minus 1 over, I'm going to plug n equals 1 in here, I get 1 over 12. Okay, n equals 2. I'm going to have 1 over 6 minus 1 over 6 plus 9 is 15. N equals 3. I'm going to get 1 over 9 minus 1 over 18. N equals 4. 1 over 12 minus 1 over 21, and so on. 1 over 15 minus 1 over 24. This is going to keep happening until I get to my last two terms. Say n equals n. And we're going to have 1 over 3n minus 1 over 3n plus 9. So what happens here is you see some terms start canceling. This 1/12 cancels with the negative 1/12. The 1/15 cancels with the negative 1/15, and so on. So eventually, you have a bunch of terms canceling, except for this last term and a few terms prior. But what you're going to do is you're going to take the limit as n goes to infinity of that sum. Notice that we had 1/3, 1/6, and 1/9 remaining. 1/3 plus 1/6 plus 1/9 plus a few other terms, and then this last term was minus 1 over 3n plus 9. I don't know why I put parentheses. So there's a few other terms that have n in the bottom, but you'll see why it doesn't matter here in a minute. Because as n goes to infinity, all of these terms are going to drop out. And then your final answer is just 1/3 plus 1/6 plus 1/9. And you may as well simplify this. This is, let's see, this is 2/18 plus 3/18 plus 6/18. And we get 11/18. So telescoping series, you actually can find the infinite sum. This is how you do it using partial fractions.